Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about the Fundamental Theorem of Calculus.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral from -1 to 3 of negative x cubed plus 3x squared plus 1 dx, and we have to evaluate this definite integral. Well, first let's go find kind of the indefinite integral using our Fundamental Theorem of Calculus here. So, the integral of negative x to the third power would be a negative 1/4 x to the fourth power, right? Take a derivative of that part, and we will get negative x to the third power. Plus, integral now of 3x squared would be a, well, x to the third power, gives us 3x squared, and then plus 1 would just be an x. Normally we would add a plus c here, but we're integrating from -1 to 3, -1 to 3. Okay? So now what is that telling us we need to have? Well, our Fundamental Theorem of Calculus says we need to plug in 3 and -1 into our equation and subtract them. So we have a -1 over 4 times 3 to the fourth power plus 3 to the third power plus a 3 minus, and it's this whole part here, minus the second part. -1 goes in for every x as well. -1/4 times a -1 to the fourth power plus a -1 to the third power plus a -1. Okay, what does this come out to be? Well, I did all that work for you. This part right here, -1/4 times 3 to the fourth plus 3 to the third plus 3 comes out to be a 9.75. Okay, minus this part here, -1/4 times -1 to the fourth plus -1 to the third plus -1 is a -2.25. Well, subtracting a negative we should know is adding a positive, and that comes out to be a 12. And so, taking the integral from -1 to 3 of our function is a positive 12. We're given this problem right here, the integral from -2 to 1 of x to the fourth plus x cubed minus 4x squared plus 6 dx, and we need to evaluate this indefinite integral. First, let's find the integral of our function as per our Fundamental Theorem of Calculus from a to b. So, our function here, we have to find the integral. What's the integral of x to the fourth power? And that's going to be an x to the fifth over 5. Same thing applies here. X to the third power is an x to the fourth over 4. Minus here, now the integral of 4x squared is going to be a 4x to the third over the 3, plus here 6 is going to be a 6x. Now we want to integrate this from -2 to 1, so we don't have the plus c part like normally, we have a -2 to 1 right here. Now our Fundamental Theorem of Calculus tells us we need to plug in f of b and subtract that to be f of a. Okay, so our a value is -2, our b value is 1. So with that, we need to plug in 1, right, into our x values here. So, bracket, this is f of 1. So we have 1 to the fifth power over 5 plus 1 to the fourth power over 4 minus 4 times 1 to the third power over 3 plus 6 times 1, right there. Close the bracket. Subtracted by, same thing, we plug in a, -2 in. So, we have -2 to the fifth power over 5 plus -2 to the fourth power over 4 minus a 4 times -2 to the third power over 3 plus 6 times a -2. That's a long one. Alright, and again this is my f of b and this is my f of a. Well, I solved this whole part here for you, so 1 to the fifth power over 5, so 1/5 plus really 1/4, minus 4/3 plus 6 comes out to be a good old 307 over 60. You're welcome. This right part here, -2 to the fifth power over 5 plus -2 to the fourth power over 4, minus a 4 times -2 to the third over 3 plus 6 times a -2, comes out to be a -56 over 15. Well, subtracting a negative, adding a positive here, you should know that. And when we add these two fractions, we get a 177 over 20, which comes out to be an 8.85. And so when we find our definite integral from -2 to 1 of our function, our final answer is an 8.85. We're given this problem right here, the integral from 1 to 3 of a 2x squared minus 12x plus 13 dx. And we have to evaluate this definite integral. Now, the first thing I want to do is find the integral, and we're going to put it from a to b here. Okay? So what's the integral of 2x squared? Well, the integral of 2x squared is a 2x to the third power over 3 minus the integral of the 12x part is a 6x squared plus the integral of 13 is a 13x. And we're integrating this from our a to b value from 1 to 3. Okay? So we know that to be, right, our f of 3 minus our f of 1. Okay? So that equals, let's go plug it in. Let's give me some space here, actually. Could be a while. So we're going to plug in 3 first into our function here, and then subtracting we plug in 1. So put a little bracket here. 2 times a 3 to the third over 3 minus a 6 times 3 squared plus a 13 times a 3 minus, close the bracket there, new one, same thing, plug in 1. 2 times 1 to the third over 3 minus 6 times 1 squared plus 13 times 1. Okay, make sure I have it all good. All right, so simplify this. Now, I've found this for you. This whole first part, this f of 3 simplifies to just be a good old 3. And the second part here simplifies, this is just algebra, to be 23 over 3. When we subtract the two, 3 minus 23 over 3 comes out to be a negative 14 over 3, which comes out to be a negative 4.6 repeating. And there we have it. Our integral, our definite integral from 1 to 3 of our function is a negative 4.6 repeating. We're given this problem right here, the integral from 0 to 3 of our function, negative x to the third power plus 3x squared minus 2 dx. And we have to evaluate this definite integral. Now, our first thing is we want to find the integral, really, of our function here. So, the integral of negative x to the third power is a negative x to the fourth over 4. Plus, the integral of 3x squared is just x to the third power. From there, the integral of 2, or minus 2, is a minus 2x. And instead of doing our plus c, we have the symbol a to b right here. So saying we're taking the integral from a to b. What that is telling us is that, well, this is our integral right here, the capital F. It's going to be an f of, well, not a to b. See, I got ahead of myself there. If you caught that, let me know. If you're confused, I'm sorry. Not just a to b, but our a value being 0, b value being 3. 0 to 3. And so that's going to be f of 3 minus an f of 0. Okay? So now let's go plug that in. What is my f of 3? We plug 3 right there into our function here. So a bracket here to hold it all in, negative, and then we have 3 to the fourth power over 4, plus a 3 to the third power minus 2 times a 3 right there. Closing it out. Subtracted by, now let's plug in 0. And I love when 0 is going because a lot of stuff cancels. Negative, then 0 to the fourth over 4, plus 0 to the third, minus a 2 times a 0. So let's go simplify this. Well, luckily for us, this whole thing I have done for you, this part, our f of 3 simplifies to be a 3/4. Minus this whole part here, our f of 0 simplifies to be 0. And so 3/4 minus 0 is a, well, 3/4. Or 0.75, but you get it. And so our final answer here for our integral from 0 to 3 of our function is a 3/4. We're given this problem right here, the integral from negative 1 to 0 of x to the fifth minus 4x cubed plus 4x plus 4 dx. And we have to evaluate this definite integral. Well, the first thing I want to do is find the integral here, using our little formula here. So, integral of x to the fifth power is an x to the sixth over 6. Let's go each part here. Minus 4x to the third is just an x to the fourth power. And then integral of 4x is just 2x squared. And the integral of 4 is just a 4x. Okay, make sure I got all. We're good. So we're integrating this from a to b, a value being -1, and our b value being 0. And so what this does now, we have the integral here. We don't have the plus c because we're doing a definite integral, and that's our f of 0 minus an f of -1 here, okay? So now we're going to plug 0 into our function and a -1 as well, and we're subtracting. I love when zeros go in because a lot of stuff basically just cancels. So we have a 0 to the 6th, but we'll show our work, over 6 minus a 0 to the 4th plus 2 times 0 squared plus 4 times 0 here. Okay, pretty easy, just plugging 0 into our function. Minus, same thing, but we're plugging -1 into our function again. -1 to the 6th over 6 minus a -1 to the 4th power plus 2 times a -1 squared plus 4 times a -1. Okay? From here, all right, we gotta simplify. Now, luckily for us, or I've done it all, this whole first part, our f of 0, comes out to be a 0. You're welcome. Minus this whole part, our f of -1, comes out to be a -17 over 6. Well, we know subtracting negatives, adding a positive, so we just have a 17 over 6 here, which is equal to a 2.83 repeating. And so there we have it. Our integral from -1 to 0 of our function is a 2.83 repeating. We're given this problem right here, the integral from -3 to 0 of a 4x to the 1/3 power dx, and we have to evaluate this definite integral. Now, we want to find the integral of 4x to the 1/3 power, and that comes out to be a 3x to the 4/3 power, to cancel it out. Now, instead of the plus c, since we're using the Fundamental Theorem of Calculus, we're going to integrate this from -3 to 0. And so what this is telling us, this is our capital F. We want to find f of 0 minus f of -3. So let's go do that. Well, brackets here, we're going to plug 0 into our function, so we have 3 times 0 to the 4/3 power. All right, minus, same thing, we put a -3 in here. So 3 times a -3 to the 4/3 power, right there. Okay, well, oops, lost my spot there. There we are. Okay, I was looking at the wrong problem. I was like, this is not correct. All right, so we plug 0 in here. We get a 0 right there. Pretty easy. We're subtracting here. Now, this simplifies here. 3 times a -3 to the 4/3 power is a 9 cube root of 3. Well, the negative is right there, so we have a -9 cube root of 3 as our simplified answer. And if we want to write that as a decimal, that's approximately a -12.98. I like it in this form better, personally. So our final answer here of our integral from -3 to 0 of our function is a -9 times the cube root of 3. We're given this problem right here, the integral from -4 to -1 of a -4 over x cubed dx, and we have to evaluate this definite integral. Now, we want to find the integral here. So the integral of a -4 over x cubed is, hopefully you can do this, a 2 over x squared. And I like to find, well, plus c, but we'll get to that in a second. I like to rewrite this to be x to the -3rd power to really see it, but our integral here is 2 over x squared. Now we're integrating this from our a to b value, so from -4 to -1, right there. Okay, all right. That is equal to our f of b minus our f of a. So that's going to be the f, capital F being the derivative here, of a -1 minus an f of a and -4. This makes it a little easier to see just kind of what we're doing here, plugging it in. So let's go do that. We're going to plug -1 into our function. Brackets here, 2 over a -1 squared. Subtracted by, we'll plug -4 in for x. 2 over a -4 squared. All right? I've done the hard work for you. Well, not really that hard here. 2 over -1 squared is a 2. Minus, and 2 over -4 squared is a 1/8. 2 minus 1/8 is a 15/8, this is just algebra, which is equal to a 1.875. So our final answer here, depending if you want to fraction or decimal, of our integral from -4 to -1 of our function is a 15/8, or which is equal to a 1.875. We're given this problem right here, the integral from -3 to -1 of 4 over x dx, and we have to evaluate this definite integral. Well, what's the integral of 4 over x dx? Well, that just comes out to be a 4 times the natural log of the absolute value of x plus c, but we're finding the definite integral, so it's from our a to b value here, which is -3 to -1. Now we know that's going to be our f of -1, I'll put -3 first, -1, Sean, minus our f of -3. That's a parenthesis. Oh, messing up here everywhere. Alright, so what we're going to do here now that we have our integral, we're going to plug -1 in for x and -3 in for x and subtract them. So we have 4 times the natural log of, absolute value, don't forget that part there, Sean, that's going to be critical, of a -1, okay, minus 4 times the natural log of the absolute value of -3. Okay? Well, 4 times the natural log of the absolute value of -1 comes out to just be 0. Minus here, 4 times the natural log of absolute value of -3, well, that just makes it a positive 3, and so we have minus a 4 natural log of a positive 3. So that's equal to -4, don't need a 0, natural log of 3, right there, and a positive 3, which is approximately, simplifying this, a -4.394. If you need the decimal, I'll get this for. But either way, we have our final answer here of our integral from -3 to -1 of our function is a -4 natural log of 3. We're given this problem right here, the integral of -pi/4 to -pi/6 of 2 cosine x dx, and we want to find the definite integral. Now, the integral of 2 cosine x is just a 2 sine of x. Pretty simple here. But we're integrating this from, using the Fundamental Theorem of Calculus, and -pi/4 to -pi/6. And our rules tell us that there's going to be our f, capital F, our integral, of a -pi/6 minus capital F of a -pi/4. So let's go plug those values in. -pi/6 in for x. So 2 times the sine of -pi/6 minus, same thing, 2 sine of a -pi/4. And sometimes, depending on the problem, I like to put little brackets around each part to kind of see that this is my f of b and this is my f of a. Well, 2 times the sine of -pi/6 comes out to be a -1. Subtracted by 2 times the sine of -pi/4 is a negative square root of 2. Now, we add a negative, right? It's kind of subtracting a negative is the same thing as adding. So we have a -1 plus the square root of 2 right there. And most places would be good with that, but if you want to write that as a decimal, it's approximately, just for you, 0.414. Okay? I prefer this form right here, -1 plus square root of 2. So our final answer here is a -pi/4 to -pi/6 of our function, the integral, is a -1 plus the square root of 2. We're given this problem right here. The integral of the square root of 2 to 2 of 1 over x square root of x squared minus 1 dx, and we have to evaluate this definite integral. Well, this looks exactly like an inverse trig formula here, definition. And this is the inverse for secant. So this lines up perfectly to be, when we take the integral, the arcsecant of the absolute value of x here. Now, instead of a plus c, using the Fundamental Theorem of Calculus, we go from the square root of 2 to positive 2. So what are we doing? We're going to take our integral, secant of -1, capital F, of the 2, and subtract that, same thing we plug in the square root of 2 in. Okay? So let's go do that. Arcsecant of 2, absolute value of 2, minus, here, arcsecant of the absolute value of the square root of 2, right there. Okay. Well, the arcsecant of the absolute value of 2 comes out to be a pi/3. The arcsecant of the square root of 2, the absolute value of the square root of 2, is a pi/4. Pretty easy. Pi/3 minus pi/4 is a pi/12. And that approximately, in case you want that, is a 0.262 in decimal form. But I prefer pi over 12 right there. And there we have it. Our integral from square root of 2 to 2 of our function is a pi over 12. We're given this problem right here. The integral from -3 to -2 of 5 of 2x plus 4 to the 1/3 power dx. And we have to evaluate this definite integral. Now to integrate this, I have to use some U-substitution here. At least I had to. So I'm going to set my U value to be a 2x plus 4. What's inside the parentheses? If that's my U value, what can I make my du value be? Well, that 5 out here, right, that 5, it's kind of hard to get because if I have my du, right, taking the derivative, I have a 2 dx here, and the 5's in the way. But if I rewrite this and I put a 5 halves out front, right, a 5 halves out front, we can write this as a 5 halves like this. Then we take the integral, I'm going to put a from -3 to -2, of a 2 in there. 2 cancels out right here. We still have the 5, we can pull that constant, of a 2x plus 4 to 1/3 power dx. And at this point, I can plug in my u value right here, right? And my du is right there. So we have the integral now of 5 halves times the integral, right, in terms of u, -3 to -2. Now, we're not going to plug it in yet, so don't worry about this stuff. I kind of keep it as a placeholder. This is for x, not for u. We're going to switch it back to x in a minute. So this is going to be a u, a u to the 1/3 power du, right there, okay? Okay, when we integrate that, right here, that comes out to be, well, a 5 halves is out front, times the integral here of u to the 1/3 power is going to be a 3/4 u to the 4/3 power. All right, and then we need a plus c, but we're not really going to have that here because we're going to do it from our lower bound to upper bound. But again, this is in terms of x, so I really shouldn't have that here. We'll plug him back in a minute, and we'll do that up here. So plugging that back in here, write it in terms of x. Let's simplify it. 5 halves times 3/4 is a 15 over 8. And then plugging instead of u, let's go plug in our u back in, 2x plus 4 to the 4/3 power. And then, like I said, normally we would rewrite this, what these values are, but we're just going to come back to in terms of x, so I don't have to. And this is from a -3 to -2. If you wanted to do it in terms of u, you would actually plug these values in for u, or in for x here to find what its equivalent u value is, but I'm bringing it back to x, so I kind of like, don't do that step because I know I'm going to bring it back anyway, okay? So, what we have here now is our, using our fundamental theorem of calculus here, from an integral from -3 to -2, and we're going to plug in, right, -2, and for x, subtract that and plug in a -3 as well. Same process as before. So let's go do that. Brackets here, 15 over 8 times a 2 times a -2 plus 4 to the 4/3 power. Subtract that by, same thing, we're plugging a -3 in, so 15 over 8 times 2 times a -3 plus 4, right, to the 4/3 power, right there. Luckily, I've done the hard work for you here. All right, when we plug in -2 into our function, it comes out to be a good old 0. Okay, and that's kind of easy to see. Subtracted by, we plug in -3 into our function, it comes out to be a approximately a 4.725. Okay, which actually is a is a 15. 15 third root of 2 over 4, okay, which is 0 minus that is just a -15 cube root of 2 over 4, which is approximately that -4.725 I have here. Got ahead of myself. So either way, however you want to write it, you'll have it there. Let's pick the first one. It's fine with me. And so there we have it. Our integral here from -3 to -2 of our function is a -15 times the cube root of 2 over 4. We're given this problem right here. The integral from negative 1 to 2 of 2 over 2x plus 4 to the third power dx. And we have to evaluate this definite integral. Now first I want to find the integral here. I'm going to find it in terms of actually u, using U-substitution, and bring it back to x. So it's a little tricky. When doing that, I'm going to set my u value to be the 2x plus 4, what's inside the parenthesis. With that being said, my du then comes out to be, right, a 2 dx. And this actually works out pretty well. We see a du right here and a u right here. So I'm going to rewrite this integral. Now I'm not going to put my bounds on the integral right here because I'm going to be writing it in terms of u and these would need to change. But I'm going to change it back in terms of x, so we'll be fine later. So I kind of ignore it right now. So this in terms of u is just going to be a 1 over u to the third power du. Okay? Well, the integral of 1 over u to the third du is a negative 1 over 2 u squared plus c. Okay? Well, since it's a indefinite integral, we're having plus c, but we'll ignore that in a minute. It's kind of a way of writing it like this. Writing it up now, we want it in terms of x. So we're going to bring x back in. We have negative 1 over 2 times a, put the 2x plus 4 back in for x, right, squared plus c. So that's our indefinite integral. Let's use it in terms of our definite integral now in terms of x. So we have it right here. This is going to be a negative, sorry, 1/2, not really like this. A negative 1 over 2 times a 2x plus 4 squared. And then instead of plus c, we're integrating from negative 1 to positive 2. And so we already have our capital F of x here. So we're going to put our formula here, f of 2 minus big F of negative 1. So what does that come out to be? We're going to plug in the values here for x and we're going to solve. Just algebra at this point. 2 goes in, so we have a negative 1 over 2 times a 2 times a 2 plus 4 squared. Minus, same thing, we're going to put a negative 1 in for x. A negative 1 over 2 times a negative 1 plus 4 squared. Right there. Okay? So let's go simplify this. The first part here, when we plug 2 into our integral here, we get a good old decimal, it's a long one, negative 0.0078125 minus the second one, plugging a negative 1 into our integral, we get a negative 0.125. When we combine them together, this actually comes out to be the fraction, right? We get plus a positive going on right there. It becomes a fraction of 15 over 128, which is approximately, if you want to round it here, 0.117. Either way, we have our answer in fractional decimal form, and so our integral here from negative 1 to 2 of our function is a 15 over 128. We're given this problem right here, the integral from negative 1 to 1 of e to the 2x minus 2 dx. And we have to evaluate this definite integral. Well, to do this, I'm going to find just the integral first. I'm going to use some U-substitution. So I'm going to set u to be what's in the exponent, 2x minus 2. My du then is just a 2 dx. So I'm going to rewrite this as the integral here, right? We can see, here's my u, and my, du we almost have, right? We have a dx, we need a 2. We need to put a 2 there. So if I put this as a 2 on the outside, all right, or sorry, a 1/2 on the outside, 2 on the inside, okay? So we put a 1/2 on the outside of the integral. That will counteract the 2 that's going to be on the inside to be the du, right? And then we have e to the 2x minus 2 dx. Now notice I'm not putting it from negative 1 to 1. I'm just trying to find what the integral is first here. So I have a 1/2 here. Let's write it in terms of u. The integral, now we have our du is 2 dx, and we have a u is 2x minus 2. So we have e to the u power du right here. Well, what's integral of e to the u du? Well, that's just going to be, we have 1/2 here. Integral of e to the u is e to the u plus c. If we want to plug x back in for u, we have a 1/2 e now to the 2x minus 2 plus c. Okay. We're going to take that knowledge here and we're going to apply it to our definite integral. So we have a definite integral of 1/2 e to the 2x minus 2, but instead of the plus c, remember we're doing this from -1 to 1. That's our b value and our a value here. This is going to be the f of b, b being a positive 1, getting ahead of myself, or behind myself here, minus f of a -1 here. Okay, so now we're just going to plug those values in for our x value here. So doing that, we have 1/2 e to the 2 times a 1 minus 2 power. Minus, same thing, we're plugging -1 in. So we have 1/2 e to the 2 times a -1 minus 2 power. From there, we need to, well, simplify here. So f of 1, plugging 1 in here, this comes out to be a, approximately here, this whole thing, this answer is going to be approximate here, but it was a decimal. A 0.5, not the first part, but the second part. Plugging that in, -1 in, we get a approximate a 0 for f of -1, 0.00916. So we round this out and we get an approximate answer of 0.491. Okay? So our integral from -1 to 1 of our function is approximately a 0.491. We're given this problem right here. The integral from -4 to -2 of a negative x plus the absolute value of -3x minus 9 dx. And we need to evaluate this definite integral. Now here's the tricky part. We have the absolute value. So here's a little trick we want to do. We're actually going to be breaking up this definite integral. The trick here, we want to find the absolute value, set it equal to 0. So -3x minus 9, and instead of setting it directly equals 0, I want to find where this is greater than 0, right? What x values cause this to be greater than 0? And we know at that value here is when we're going to have a turning point. Subtract 9 to both sides, we have -3x here, still greater than 9. Divide both sides by -3x, flip the sign, is less than a -3. So when x is less than a -3, we'll have a value that's greater than 0 inside of the square, or sorry, inside of the absolute value. But when x is greater than -3, okay, we're going to have a negative value in here. So we're going to have to do something when we find our integral here, or rewrite this in two parts, okay? So this is what we're actually going to do here. We have the integral here of -4 to, I'm picking -3 as my value here, okay? We rewrite this as -x plus, and notice we said when x is less than -3, we have a positive value inside of the absolute value. So we don't need to have the absolute values there. So we do that, we just have our -3x minus 9 right there, dx. Then I'm going to break it up to be from -3, that value we found, to the final endpoint of -2. Same function, -x, but here's the tricky part. Between -3 and -2, our absolute value inside is going to be negative. We don't want that. So to counteract that, to make sure it's positive, we're going to put a negative outside here. So instead of adding, we'll subtract or plus a negative, if you want to see it like that, plus a negative on the inside, -3x minus 9 dx. Okay? A lot of stuff going on here. Well, first let's go simplify this out a little bit here. -4 to -3. -x minus 3x minus 9. Okay, well -x minus 3x is a -4x minus 9 dx. Plus the integral from -3 to -2. Same thing here, but we'll distribute that minus sign across. -x will plus a 3x is a positive 2x. And then we have plus a 9 dx. Be careful with your negatives here. At this point, we'll just go apply the Fundamental Theorem of Calculus. So, we want to find the integral of -4x minus 9 dx. That comes out to be a -2x squared from, right? Oh, I forgot. Oopsie. Minus the 9, minus 9x. I almost forgot the second part. So the integral of -4x minus 9 is a -2x squared minus 9x. And we're going to do that from -4 to -3. Plus here. Same thing. We want to find the integral here. So we have integral of 2x is a x squared plus a 9x. And we're going to integrate this from a -3 -3 to -2. Okay? So, just kind of save room here. We're going to plug this in. We plug f of -3 in, right, into our function, minus f of -4. Let's call this f1 here, plus, let's call this moment f2, f2 of a -2 minus f2 of a -3, right there. So then, we want to find f of 1 of -3. Plug -3 into our integral, the first one here, and that comes out to be a positive 9 when simplified. Then we subtract there, plug in -4 in for x for f of 1, and we get a, what did I get here? A 4. Okay, so 9 minus 4. Plus, second integral right here, it's going on. We're going to plug -2 in for our x value, and we get a -14. We plug a -3 now into our x value of our second integral here, and we get a -18, where we're subtracting that here. So subtracting -18, same thing as adding a positive 18. All of this simplifies. 9 minus 4 plus a -14 plus a positive 18 is a positive 9 when it's all said and done. So our integral from -4 to -2 of our function when broken up is a positive 9. We're given this problem right here, the integral from 0 to 3 of f of x dx. And our f of x is a piecewise function of x over 2 minus 1 when x is less than or equal to 2, and x squared minus 6x plus 8 when x is greater than 2. And we have to evaluate this definite integral. Well, first let's go break up this to be two integrals here, okay? So what we're going to do, we have the integral. They tell us something happens at 2, right? We're changing the function here right at 2. So we're going to find the integral actually first from 0 to 2, and that happens when they said x is less than, right? X is less than or equal to 2. So that would apply right here from 0 to 2. So we use our first part, our x over 2 minus 1 dx, plus the integral now from the next value, 2 to 3, for our piecewise function here. That happens when x is greater than 2, and we use the second part here, x squared minus 6x plus 8 dx. Okay. So now what we want to do is integrate each part individually and then solve. So given some space here, make sure I have enough space. Our integral of x over 2 minus 1 dx comes out to be an x squared over 4 minus x. And we're integrating this from 0 to 2. Plus the second integral here, the integral of x squared minus 6x plus 8 is an x to the third power over 3 minus a 3x squared plus an 8x. We're integrating this from 2 to 3. Okay? So then from here, we want to plug in our values, right? We're going to plug 2 in for x and then 0 using our Fundamental Theorem of Calculus here. So we plug 2 in for x, and we have a 2 squared over 4 minus a 2. Subtract, same thing, we plug 0 in. So we have a 0 squared over 4 minus a 0. Got that. Plus, now we're going to do the same thing, put 3 in for x value here. 3 to the third power over 3 minus 3 times 3 to the second power plus 8 times 3. Subtract that when we plug 2 in for x here. So we have a 2 to the third power over 3 minus 3 times 2 squared plus 8 times a 2. A lot of writing here. Well, luckily I did all the hard work for you. 2 squared over 4 minus 2 comes out to be a -1. Minus 0 squared over 4 minus 0 is a 0. Pretty good here. Plus 3 to the third over 3 minus 3 times 3 squared plus 8 times 3 is a good old 6. And then subtract here 2 to the third power over 3 minus 3 times 2 squared plus 8 times 2 is a good old fraction, 20 over 3. When we combine all this together, -1 minus 0 plus 6 minus 20 over 3, we get a -5/3, which is equal to -1.6 repeating, however you want to write it. Either way, we have our final answer. Our integral from 0 to 3 of f of x dx of our piecewise function is a -5/3. We're given this problem right here. the integral of negative 5 to 1 of a negative absolute value of x squared plus 4x dx. And we have to evaluate this definite integral. Now this is a tricky one, and I first see this absolute value, and we need to figure out what x values we need to plug in. How can we rewrite this, okay, without the absolute value, but still have the rules of the absolute value apply. So I'm going to take what's inside of the absolute value, x squared plus 4x, and we'll see where it's equal to 0. Pull out an x, we have x times an x plus 4 equals 0. X equals 0, so each part equal to 0, x plus 4 equals 0, and x equals a negative 4. So we have 0 and negative 4 are my two main values here, okay? So we're going to rewrite this to be without the absolute values, but we're going to have to do a little trick. So first we have our lowest value, so negative 5 to negative 4. So the integral from negative 5 to negative 4 of a negative, and then we have what's inside, the x squared plus 4x right here, dx. But I want to see if I need to cancel this out to see if I need to put a negative outside to cancel out this x squared plus 4x right there. Well, between negative 5 and negative 4, what happens on the inside? Well, if we plug in, let's say, a negative 4.5, negative 4.5 squared is a positive number that's going to be greater than negative 4 times a negative 4.5. That's between these two values here. And so therefore, it's going to be positive on a range from negative 5 to negative 4. So we're good, so we don't actually need to change anything here. Add integral, next area is negative 4 to 0. Same thing applies. Between negative 4 and 0, what happens? Let's plug in a negative 1, let's say. Negative 1 squared is a positive number, but 4 times negative 1 is a negative. We have a negative inside of this absolute value. So what we're going to do is, we have the negative, it's already out there, we need to put a second negative, and then we still have the x squared plus 4x dx. And hopefully you can see negative, negative makes it a positive. Lastly, when you add again, we're going from last one, 0 to a positive 1 here. 0 to 1 of our function here. And between 0 and 1, let's put a 1/2. All numbers are positive. It's going to be a positive inside of the absolute value here. Don't need to change anything. Minus a x squared plus 4x dx. Okay. Well, let's go evaluate each one of these integrals here. Okay. Well, to do that, we have the integral, this negative sign, remember, gets distributed. The integral of x squared plus 4x with a negative, so negative x squared minus 4x is a negative x to the third power over 3 minus a 2x squared. And we're integrating this from a negative 5 to negative 4. Plus, same thing here, integral of x squared plus 4x is an x to the third power over 3 plus a 2x squared, integrating this from negative 4 to 0. Plus, same as before here, we have is a negative x to the third over 3 minus a 2x squared, and we're doing this from 0 to 1. Okay, a lot of work here, so keep everything lined up. We're going to rewrite this now. We're going to plug in our f of b and f of a for each one here. Okay, so we're putting negative 4 in for x. So let's put a little bracket here around what we're doing. Negative 4 in for x. So negative 4 to the third power over 3 minus 2 times the negative 4 squared. Minus, same thing, we plug negative 5 in. Negative 5 to the third over 3 minus 2 times the negative 5 squared. Plus, all right, we're going to deal with the second one right here. Okay, this can be right here. Got to write smaller here. So plug 0 in first. 0 to the third power over 3 plus 2 times 0 squared. Minus, plug in negative 4 into my function here, the second one. Negative 4 to the third over 3 plus 2 times negative 4 squared. Plus, we're on the last one. Hopefully I have enough room. Put 1 in for x, so we have negative 1 to the third power over 3 minus 2 times 1 squared. Minus, put 0 in, luckily it just goes to 0, but I'll show the work. 0 to the third, negative 0 to the third, over 3 minus 2 times 0 squared. And that should just be in. Alright, so all that lovely work here, let's go simplify, and I've done the work for you. This whole part right here, when we plug -4 into the first integral, we have a -32/3. Minus, we plug -5 in, right here, the second part, -5 goes in right here, that's a -25/3. Plus, when 0 goes into the second integral, we have a 0. When -4 goes into the second integral, we have a 32/3, and we're subtracting that. Okay? Plus, when the last integral now, we plug in a 1 into the last integral, we have a -7/3. Minus, we plug 0 into the last integral, we get a 0. So, all that comes out to be right here. -32/3 minus a negative, or plus a positive, 25/3, plus 0 minus 32/3, plus a -7/3, minus 0 comes out to be, I did all the good work for you, -46/3, which is equal to a -15.3 repeating. So after all of that, splitting it into 3 different definite integrals to solve, our integral from -5 to 1 of our function with the absolute value is a -46/3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.